Okay, I want you to take your ruler. I gave you graph paper because we're graphing, and I'd like you to take your ruler and do exactly what I do because I don't want your graphs to be itty-bitty that you can't see anything on them. So would you, on the left-hand side, we're going to start our y-axis. I want it 8 units tall, please. 8 boxes tall. Take your ruler and do a vertical line, 8 boxes tall. They don't have to make them. Okay, and then in the middle, 4 boxes down, draw your x-axis. Yeah, in the middle of 8 would be 4, right?
Just as long as it's on the board.
The y-axis needs to be 8 units tall. The x, notice mine, extends most of the way across the page. And if you need, like Joseph, yours is definitely going to be longer. Anna, you need to go to take the axis test. Okay, now for our labeling, what we're going to do is put arrows on the y-axis and mark the 4 boxes, and 4 up is going to be height of 1, 4 down is going to be height of -1, and label it your y-axis. 4 up is the height of 1, 4 down is -1, and label your y-axis. Okay, now the x-axis technically is not going to be the x-axis. It's going to be the theta axis. What is theta? Danny?
Isn't it like the answer of sine or cosine?
Very close, very close. You said sine and cosine, I agree with it. It relates to sine cosine. Remember that symbol?
Mm-hmm.
It's the angle measurement. Okay? So, for our purposes, we're just going to count by 45-degree angles, but we're writing them in radians. So I would like us to spread this out along the horizontal axis. So every other box I'm going to label. Okay, so we'll skip over 2 and label your first 45-degree angle, which would be pi fourths. Okay, then skip over another 2. We're at 90-degree angle, which is a pi halves. Adding 45 more degrees, we'd be to 3 pi fourths. So you should be skipping every 2 and labeling. And then 1 pi. That completes 180 degrees, so we're halfway around the circle. Okay, 180 plus 45 puts us at 225, which that radian is 5 pi fourths. (270 degrees in radians is 3 pi halves. Then 7 pi fourths. And then 1 full rotation is 2 pi. And instead of putting this as the x-axis, I'm going to label it with theta and put arrows. Okay, so again, in order it says pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 7 pi fourths, and 2 pi. That tastes nasty. Ugh. Yeah. Okay, first we're going to be graphing the sine function. Okay, sine is actually spelled S-I-N-E, but the abbreviation is S-I-N. Okay, please don't rotate those around in your pencil. All right. So 8A has already put theirs up on the wall. We have a sine wall in the back. Would everyone turn to the back? Look at the sine wall and then come to the right by the clock. Look at the cosine wall. I want you to notice similarities and differences between sine and cosine. Raise your hand when you notice a similarity or difference between sine and cosine. I asked you to raise your hand, please. Okay, Ariana?
Pi is always going down.
In which one?
I don't know. Both? No? Sine.
I would say cosine. Yeah, cosine, it's negative. Okay, let's go for a similarity. That's probably more of what I want to hear. No, a difference. I lied. A difference between sine and cosine.
Sine's longer, cosine.
Okay, Sela's been raising your hand patiently. Sela? Oh, so the curves are different, right? So she says it starts up and then it dips down and then it goes up above the x-axis. Versus sine, where does it start? It starts above the x-axis and goes below the x-axis. So when we look at cosine from 0 to 2 pi, we're really seeing like 3 sections. And sine, we're seeing 2 sections. Okay? What's the height of the first bar on sine? What's the height of the first bar? It's actually 0. Versus what's the height of cosine's first bar? 1. So, would you say that cosine starts at a maximum and sine starts at a 0? Do you agree with that? Cosine starts at the maximum point versus cosine starts at the halfway point, which is a 0. A 0 is an x-intercept, which is also called a solution. You've heard that before, right? We've done this before. 0, solution, root. Okay, so when we draw our sine graph, there are 3 crucial points. There's your maximums, your minimums, and your zeros, where the graph is crossing the x-axis. So sine, we can look back there and see that it's actually starting at a 0, which is an x-intercept. Okay, so take your pencil, please, and put a point right here at the origin, because it's starting at an x-intercept. Okay, look back at sine. How many times does it cross the x-axis by the time it gets to 2 pi? Take a look at sine. Guys, you actually have to turn around to look at that. Turn around, please. There's like 10 of them for you to look at. How many times does it cross the x-axis? I say it's more than once. How many times does it touch the x-axis? A curve. Touch. Because we're only looking at a small window. Technically, it does keep going in this pattern forever, so it's going to overlap. Nope. There it is, Arbor. 3. It starts at from 0 to pi, it starts at the x-axis, and then it curves up, it then curves back down and crosses at pi, then it curves down below the x-axis and comes up, and crosses again at 2 pi. So please mark those 3 points. We have one at 0, pi, and 2 pi. Now in between those zeros, it will hit maximums or minimums. So again, look at sine, and will you point, please? Is it going to hit a maximum for the first part or a minimum for the first part? Between 0 and pi, does it hit a maximum? Point up if you think it's a maximum, point down if you think it's a minimum. Good. Okay, so that's halfway between. Halfway between 0 and pi is pi halves. So here at pi halves, will you mark up to, since we're doing the unit circle, those graphs are made off the unit circle, our radius is 1. So our maximum height will be 1. Okay, and then halfway between pi and 2 pi, we hit a minimum at 3 pi halves coming down to -1. Please also label min and max like I've done. Okay, once you have those points, we're going to carefully draw the curve. So it's a semicircle from 0 to pi. So make sure you don't go any higher than this maximum point. A semicircle from 0 to pi. And then we have another semicircle but flipped upside down from pi to 2 pi. And then it ends with arrows because technically this is only one cycle and it keeps going over and over and over. Okay, it's oscillating back and forth forever in this motion. Okay, we're going to draw the other function, cosine, now. So label cosine, and then same idea as sine. I'd like you to draw a vertical y-axis, 8 units tall, please. A y-axis, 8 boxes tall. And then not an x-axis, but a theta axis extending across. And we're going to do the same labeling. So the y-axis is still counting up 4. We'll label as height 1, counting down 4, minimum 1. Are you okay? Having a back spasm? Standing helps? Okay. Okay, the x-axis, or not the x, excuse me, the theta axis, the horizontal axis, we're going to label the same units that we had above. So just copy what you did on the last one, counting every 45 degrees. All the way to 2 pi. And then label it theta with arrows. The horizontal axis is theta. Okay, take a look over at cosine. We're going to figure out how many times does it touch the x-axis from 0 to 2 pi. So hold it up in the air, please. How many times does it touch the x-axis from 0 to 2 pi? Sine we saw touch 3 times. How many times does cosine touch the x-axis? Thanks for showing me. From 0 to 2 pi. Okay. I see 2 different answers. I see 2 and I see 4. Who can explain theirs? Haley, can you explain yours, please?
It's 4 because it hits the very start of the graph and it's once, and then it goes up and hits twice, and then down and up it's once, and then it ends again.
Okay, so I see the confusion a little bit, actually. It's the top of the pipe cleaners is what we're looking at, creates a curve. So the curve actually only hits twice. It's just we've cut it off. We haven't continued the curve left on the left and the right sides. So it should actually be 2 times. So it crosses here at pi halves and at 3 pi halves. So will you put those 2 intersection points? Yeah? Because we had pipe cleaners like this. And so the curve is at the top of the pipe cleaners, and it started on the x-axis, and then it went up and back down to the x-axis, and then went below and came back up. Does that make sense? Okay. Good questions. All right. But cosine doesn't start at a 0, actually. It starts at what? We have maximum zeros and minimums. Cosine starts up high, right? So it'll be called the maximum. So we're going to actually start up here at a max, so write max at 1. And then it's going to curve down to pi halves, where it crosses the x-axis. After pi halves, we can see all of our diagrams over there. It dips below, correct?
Yeah, and it goes down to like on pi or something.
Yeah, it goes into the negative side. And halfway between pi halves and 3 pi halves is pi. So it's all symmetrical. So the midpoint would create the minimum point. So when you draw your semicircle upside down, make sure you don't ever dip below -1. And -1 should happen at pi. Then it comes back up to a maximum. So this one's showing 2 maximums. Now, if we were actually to continue this curve to show the arrows, do you need to go to the office? Do you need to go to the office? Yeah. Do you need someone to go with you?
Yeah, I'll help you. One more for sure.
You'll make it okay? Okay. I think he'll be okay. Here, let me write you a note. There you go. Okay, feel better. Okay. So, if we were to continue this curve, remember right here, it can't go any higher than this point. So on the left-hand side, it's going to actually start curving down. So to show the arrow, you need to curve it down. Same with here. It's not going to go any higher than this point. So after this point, it starts curving back down. So show a curve down and then put your arrow. So it's going to keep going up and down, but it will never go higher than the maximum point 1 or lower than the minimum point -1. Okay. So these are the 2 you're supposed to do for homework. Now each of these have, we've talked about these vocabulary words already, a period and an amplitude. Raise a hand who can remind us what a period is on these functions. Yeah?
on going, that's more than 360 degrees.
Right, yep. It just keeps going up and down forever. So it can go past 360. It just keeps repeating the cycle. Just goes up and down, up and down, and up and down.
A period is a stop. It's a stop. Oh, wait, did I learn that?
In English. That's a period in English class. But you know what? That's an idea. We could apply that. Arbor?
And that's where, like, from one point to the graph and the other way, like,
It's the horizontal distance. See, so in English, you start with a capital and you end with a period, right? And that completes a sentence. So in math, we're completing the cycle. So the period is that horizontal length from starting point to ending point. Okay, so sometimes it's most convenient to look at maximum to maximum. Other times it's most convenient to look at zeros to zeros. Here I would say I'd go from maximum to maximum. So I'm going to follow this curve. Yep, the horizontal distance. Styles? You have something on your lap you need to put away? Please put it away. Please tell me when to stop when I have completed the cycle. Please tell me when to stop when I've completed the cycle. I'm starting here. I'm going to move along until I start going down, because that one was going down. There you go. Great. So the period is the horizontal distance from one starting point to the end point. Okay, Amy? Yeah, it's back there. Okay, Austin, what would you say this horizontal distance is from there to here?
From where to where?
From our starting point to our ending point. Neither, actually. Shh. It's what, Austin? 2 pi, exactly. So, let's write that right here. So the period is 2 pi. Now the amplitude is the other one we're going to focus on. Remember, amplitude is the mountain height or the valley depth. And it's really nice when it's oscillating around the x-axis. Okay, because you can just look at the maximum and minimum values. For instance, here's a valley. How low does that go? -1. So how high does this mountain go? 1. So the amplitude is the positive form, the absolute value. So in this case, our amplitude is 1, which is actually the radius of our circle, right?
Stands for what?
Amplitude.
Yeah, but why 1?
It's the height of the mountain
Oh.
from sea level. Sea level is our midline, which in this case is the theta axis. Okay. So this is for cosine. Let's go up to sine. Okay. Cosine for period, we started from peak to peak. But here I don't see 2 peaks. So in sine, I think it's actually easier to look at from 0 to 0. Please tell me when to stop when I've completed the cycle. Here's my starting point. Tell me when to stop when I've completed my cycle.
stop.
No, actually. Do you see the slope right here is down? But when I started, the slope was up. So I started with a positive slope. So, yeah, so we need to go until I have a positive slope going up again. No? There we go. Now we have the positive slope. Okay, so from beginning point all the way to ending point, Macon, what's that period, that horizontal length from beginning to end? 2 pi also, yes. So our period again is 2 pi.
So the answer for period is just wherever the cycle stops.
Yeah, it's how the width of the cycle. Yeah, I guess. Usually we say them in radians, but technically that's the same thing. So here's the idea. Just like in algebra, if the story problem starts with fractions and it doesn't work out nicely, if it starts in fractions, you'd write your answer in a fraction. If it started in decimals, you'd write your answer in a decimal. So kind of like here, if it starts in radians, then keep your answer in radians. But if the horizontal axis was all in degrees, then you could say the period in degrees. Does that make sense? Okay, sweet. Oh, what is our amplitude? Yeah, it's also 1, right? Okay, so yes, sine, cosine. Now we have some properties of the sine function, which actually also apply to cosine function. We'll just focus on sine, and then you can apply the same idea to cosine. Properties of the sine function. No, just below your graphs. Okay, so if you recall, don't write this part down over here on the right because I'm going to erase it. But you remember we've gone through with your math last year and this year, we've done lots of AH's and K's. Remember quadratics? You don't have to write this because I'll be erasing it. Absolute values. Remember these AH's and K's? There's lots of functions with AH's and K's. What else? Square root function. There's like 8 of them, I think. Okay, well guess what? AH's and K's also happen in sine and cosine. You guys all sigh. Okay, suppose, no, you shouldn't hate them because the same pattern happens every time, which means it should be easy because the same pattern happens every time. Okay, suppose y equals a times sine b theta with, so I'm going to erase these. Yes, you do write the blue part. Suppose we have y equals a times sine b theta with a can't equal 0, which makes sense because a is your multiplier. If you multiply by 0, then it's no longer sine or cosine, it's just 0. So it's not going to be a wave. So a cannot be 0. Also, b has to be greater than 0. Okay, and theta has to be in radians. Kind of like with our arc length formula, it has to be done in radians, not in degrees. Yeah. Meaning it has to be positive. There are a few trig questions on the ACT. Suppose you have a sine function that has an a and a b, which means there's a multiplier by sine, and there's a multiplier on theta. We should already know what a does to the graph, because like I mentioned, we have AH's and K's on all functions. We'll talk about the H and the K, the shifting, later on, not today, but there is an H and a K that comes in sine, which gives a horizontal shift and vertical shift. But right now we're looking at multipliers. By raising a hand, who remembers what the A does to any of the functions? South? No, that's the K actually. And so the horizontal and vertical shifts will come on another day. It could determine if it's negative or positive. If it's positive, it's going to be normal. If it's negative, it's going to be flipped.
Or if it's greater or less, because if it's like a fraction of the...
Yeah. What do you mean by greater or less, though?
Greater or less than 1.
Yeah, what on the graph is going to be affected if it's a fraction? You don't remember that, Noah?
Stretch.
Yeah, it's the stretch and the, what's the opposite word? Compression. So it affects the steepness of the graph. Which for us, watch my hands. Steepness is actually the amplitude, right? So the flatter our amplitude is, and are my arms forming a hill or a mountain right now?
No.
A hill, but the steeper the amplitude gets, which means A is increasing, we get more of a mountain. Okay, so absolute value A shows us the amplitude of the function. Okay, so there's a multiplier in front of sine. It's telling you how tall the mountain is or how deep the valley is. Okay, B, which is our multiplier to theta, B is the number of cycles in the interval 0 to 2 pi. Number of cycles in the interval 0 to 2 pi. So how many times it repeats the pattern between 0 to 2 pi. And finally, 2 pi divided by b, which really is 2 pi divided by, whoops. Okay, 2 pi divided by the number of cycles, because remember b is the number of cycles from 0 to 2 pi. That tells you the period. This tells you the period of the function. And the period is the horizontal width that it takes for one cycle to complete. Okay, so we're just going to do one example where I'm going to give you specifications. You need to sketch the graph and write the function of the graph based off of information given. At first you'll think it might seem a little difficult, but really it's not that bad if you know these properties up above. Okay, so still on your graph paper, we're almost done. For example 1, we're going to give you the amplitude is 1/3 and the period is pi. Your job is to sketch the graph and write the equation. Okay, it's really not that bad. I'll step you through this first one. There are a couple just like this on your homework.
Wait, so what are the equations for the first two that we did?
We wrote them. It's just y equals cosine theta. Y equals sine theta. Well, if you notice, theta is just 1 theta, so we had 1 cycle by the time we got to 2 pi. Here, cosine theta was 1 theta, so we only had, and the amplitude was 1, we only got 1 cycle by the time we got to 2 pi. So, my personal preference is to start with the equation, because it's really easy, because we're given A and we're given B.
So it's just, so it's y equals 1/3
Mm-hmm.
sine pi. No?
Okay, almost. Does everyone understand where she got 1/3? A was the amplitude and that was given to us. Okay, so y equals 1/3 sine, but B is not pi, because pi is the period. What B is the number of cycles in the interval 0 to 2 pi. So it takes 1 pi, so a quick rough sketch. It's going to go through the cycle once by the time it gets to pi. How many times does it go to the cycle by the time it gets to 2 pi? Twice. So therefore B is 2. That is your equation, and then we'll graph it.
Why is it pi at the middle?
You don't need pi.
Oh. How do
You put theta. Okay, I'll show you. It's not hard. Okay. Any questions? Any more questions on like how we get the 1/3 or the 2?
Wait, if it's just one, if it's just, that's just,
Yeah, how'd you get the 2?
yeah, I do get the 2 and the 1.
It tells you right here that the period is going to be completed after 1 pi.
Oh.
Okay, how many pi's are there in 2 pi? There are 2.
Where'd you get?
This part is given to you.
So like, you start counting after the 1.
Yeah. That's what B is. It's always how many times it completes the cycle in 2 pi. Okay, one last graph. Draw 8 tall, please. 8 tall. And your horizontal theta axis. This time on the y-axis, though, because I see that this is a 3, and I kind of know what's going to come up because I've done these before. I know 4 isn't divisible by 3 really nicely, right? Because before we counted up 4 boxes. What's a number that's divisible by 3 besides, that's better than 4? 2 is not divisible by 3, no. 3 itself, yeah. So instead of counting up 4, I'm just going to count up 1, 2, 3, and mark that as 1. So on our y-axis, we're actually, instead of using all 8 boxes, we're going to just use 3 up and 3 down. Because I know my amplitude is 1/3, so I want something that's divisible by 3. I don't want to use 4. Okay, your theta axis will be the same, so copy what you have above. Copy what you have above. Pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 7 pi fourths, and finally 2 pi. With arrows, you need to label this axis as theta. Okay, the first 2 graphs, we started plotting specific points. On cosine and cosine, did we start plotting the maximums first, the zeros first, or the minimums first? Every time, both the graphs above, we start with the zeros. Okay, sine we'll always have until we get into horizontal shifting. Right now, for today's purposes, it will always have the same zeros. So look at your graph above for sine. Show me how many zeros there were. Raise it up high. How many? Thank you. How many times did it touch the x-axis? Raise it up high. It didn't touch 5 times. There's less than that.
1, 2, 3.
How many times did sine touch the x-axis? Excellent. 3. So we'll have them in the same place. 0, pi, and 2 pi. We will do the same here. Oh, I lied. I forgot we have this 2. I forgot we had this 2. This 2 actually tells us it has to complete the circle by the time it gets to 2 pi. So sine goes up and then down. So what's halfway between 0 and 2 pi? Pi halves. Okay, so it's going to go up, and your upper semicircle is going to be done by pi halves. Your lower semicircle will be between pi halves and pi. However, how tall are the mountains? Does it go all the way up to 1? It only goes up to 1/3. So this first semicircle is going to go up to the first box. That's why we did 3 boxes, because 1 box would be 1/3. And then it comes down 1 box. And it has to be done with the cycle by the time it hits pi, because that's what it tells us right here and right here. And that continues halfway between 2 pi and pi. I haven't had much coming from you guys over here. What's halfway between pi and 2 pi from this side of the room?
3 pi over 2.
Excellent. So 3 pi over 2, that will finish be the transition point between our upper and lower semicircles. Does that make sense? So come up 1/3 and then down 1/3. And then make sure you end with arrows, and that's your graph. See, you've shown the amplitude, and you got that the period was from 0 to pi. Okay, so you'll be doing that with, you have already your graph paper. You'll be doing that with sine and cosine for your homework. We will have, because tomorrow is kind of a weird schedule, it's starting off my A day. So on your B day, on Wednesday, we will be spending some time in class going over questions but your job is to still come with most of it done. Okay, so here's the sine assignment. The first one's sine. The second one is cosine. I already told you we will spend some time in class doing these, but you need to come with most of them done. We will spend, I know it's longer, but I keep saying over and over, we will spend time in class doing some of these next time. But you need to come with a good chunk of it done. Does that make sense?
Yeah.
So next time, are we going to spend some time on these? Yes, but what's your responsibility? To try most of them. Okay, let me stop this.